Second problem of sliding on the pattern, and you can see the problem is nothing but minimum size Subarray sum. Okay, and yeah, this is the second problem, and we already completed our two pointer pattern. You can check out the playlist in the description. Okay, so this is the second problem of sliding on the pattern, and we are given that we are given an array of positive integers and the array name is nums. Okay, and you're also given a positive integer target. So basically what we need to do, we need to return minimal length of subarray. Okay, so you can check out the definition of subarray. This is nothing but a contiguous non-empty sequence of elements. Okay, so we just need to return the minimal length of the subarray, okay, whose sum is greater than or equal to the given target. Okay, so yeah, if there is no such element, then we need to strictly return 0 instead. Okay, so you will able to understand with this example also. You can see this is the example, this is the given array, and we already mentioned that every element will be positive. Okay, positive integer. So this is the target, so we just need to find the minimum subarray. Okay, subarray that will provide a sum that will be equal to this target or greater than this. So if you carefully notice this array, you will able to you'll able to find that 4 and 3, this subarray, the length of this subarray, two size this subarray, well, the sum is nothing but 7. So you can see this Savary sum is equals to the target. So we can see the minimum Savary length that will provide, sum of 7 or greater than 7 will be nothing but length of 2. Okay, so this is the thing. Now let's analyze this examples to find out our solution. Okay, so this is the example. You can see this is the first example. We have our target 7 and we have this array. Okay, so basically what I need to do, as we already discussed, we need to find just a sub array, minimum length sub array that will give the sum uh, greater than equals to this target. Okay, so you can say this sub array. Okay, the sub array start from this index to this index, so the length of 2 will give a sum of 7. So this will be the minimum one for this array. That's why we need to return the length. Okay, and the length is nothing but 2. That's why 2. Okay, and for this array the target is 4. So this single element can give this result. That's why the length of array will be 1. Okay, that thing. And if we talk about this array, okay, if talk about this array, so you can see the target is 11, but if we consider the whole array, okay, as a array, but still it not complete the target. That's why we can say no such elements is exist. That's why we need to return 0 here. Okay, so that's the thing. Now let's discuss the approaches that we can follow to solve this problem. So basically we can apply a very brute force approach that will be nothing but using nested loop. Okay, so what I can do, let's say our outer loop will start from this will be, let's say, I position. Okay, and we'll be using another loop inside this loop. Okay, so that will, let's say, j will start from I plus 1. So every time it will also j will continue up to n. I will continue up to n and j will also continue up to n. Okay, and so basically with the help of j pointer will be adding every current element to the let's say we'll be having a sum, and we'll be adding current element to this sum, and basically we'll be checking this sum is greater than equals to this target or not. If this greater than equals to this target, then we simply break from the outer loop. And yeah, we also need to check the length of the subarray, so that over the process we can return the minimum length. Okay, so that we can, over the process we can return the minimum length. Okay, so you can see this is a very brute force approach. So we'll be having two loops, one will be outer loop, okay, and one will be inner loop. Okay, so yeah, using this inner loop we'll be adding the sum, and we'll check when the sum is greater than this, greater than equals this target, then we'll simply get out of this inner loop. Okay, and we'll simply throughout this process maintain a minimum length, not sum, actually minimum length, so that we can able to return the minimum sub array length. Okay, so this is a very good first approach, you can say. And if we talk about the time complexity, you already know the time complexity will be nothing but big of n square, right? For this nested process, big of n square will be the time complexity. So now let's talk about another process that will be optimal, and that is nothing but the sliding window process. Okay, so we just need to apply the sliding window pattern, okay, or approach to solve this problem. So what we'll be doing, what is the sliding window approach? Basically, we just need to take a start pointer, okay, to start our iteration. So you can say this is, and our start point will be nothing but it will start from 0 always. Okay, so you can say this is the start pointer. Okay, you can say this is the start pointer, and we also need to iterate through the array. Let's say this will, and the array will, we just need to iterate through the array, right? So we'll be using a for loop. Let's say I will be the iterator for for loop, and it will also start from 0. Okay, so first of all I'll be here. You can say this is I, the position of I. Okay, so in the sliding with the process, what we did, we actually, every time we just keep adding the element to a sliding window, okay, to a window size. Okay, and while we get a required sum according to the condition, then we basically shrink the window from the beginning. Okay, so let's say this is the window size first, then while that, let's at this position we get our target value, or we achieve the condition. Then what we'll be doing, we will further move the window to one step further, and we'll sync it from the beginning. So you can say this, we will sync it from the beginning and we'll move one step further. Okay, so this will the sliding window approach. So now let me tell you what will be the approach, exactly what we'll be doing. Okay, so you know what I need to do, we just need to use this for, okay, let me erase this first. Okay, so basically what we'll be doing, we'll be using this for loop to iterate through the array, and it will iterate up to what, up to the length of, you can say up to n length of the array. So every time we'll be taking a sum, let's say we'll be taking a sum. Okay, every time we'll be adding the current element to this sum. Let's say initialize the 0, and we know that we just need to return the minimum length. So we'll be using a variable, let's say this is minimum length, and we'll initialize it. As we need to return the minimum, we need to initialize this with maximum possible. Let's say it will be maximum value. Okay, let's say it will be max value, and in Java we have a variable integer dot max value. We'll be using that. Okay, okay, now what I need to do, every time we just need to add the current element to this sum. Okay, let's say we have a sum. Let's say we have a sum sm. Okay, sm means sum. Okay, and we just need to add the current element to this. Okay, so let's say current element is nothing but cv current value. Okay, and what he did, what he said, we said that in the sliding window process, when we reach reach a specific target sum, then what we need to do, we need to shrink the window from the beginning, and we need to step the window one step further, right? What I need to do, and here for this problem, as we said that we need to achieve a target of 7 or less than second. And so what I need to do, we need to simply, for shrinking this, we need to have a condition. Let's say our condition will be nothing but this sum. Okay, for this problem, the sum, let's say this sum, until this sum is greater than equals this target. Okay, greater than equals this target, then what we'll be doing, will be we'll try to shrink this window. We can say we'll try to shrink this window so that we can able to find a minimum length. Okay, so if we talk about this problem, you can say this, right now start is here and our I pointer is here. So right now current sum will be nothing but 2. Okay, current sum will be nothing but 2. So you can say this. Okay, we'll be doing something in between this loop. Okay, for now let's keep this empty. Okay, so now we can say the current sum is 2. Okay, now what we'll be doing, we'll keep on running with this loop. So I'll increase by 1. Now I will be here. Now the sum will be what, plus 3. Okay, now we just need to add the 3 to this sum. Okay, now you can say right now the sum is nothing but 5. This doesn't increase this this target value, so we are not going to enter this loop. Okay, again the I will increase by 1 pointer and I will be here. So right now the current value is nothing but 1, so we'll be adding 1. Okay, so you can say the value is nothing but, right now the value is nothing but 6. So this condition doesn't satisfy, so it doesn't enter into this loop. Okay, so what I need to do, again we need to increase the, again the I pointer will increase and I pointer will be here actually. So right now if we add the current value to the sum, okay, so you can able to see the sum is nothing but 5, 6 and 8. Right now the sum is 8, so you can, right now you can see this sum is greater than equals target, so this condition satisfies, so it will enter this loop. So right now you can see we achieve a target sum. That we actually need to do, we have said that we need to find a subarray that will, you know, provide a sum that will be greater than equals to this target. So we are here right now. What I need to do, we simply need to check the, you know, check the length of the subarray. So how can we get the length of subarray? So we have a starting pointer, okay, and right now I will give us the last pointer. So for the, you know, whatever, for this length, so what we can, you know, the length will be nothing but what, the difference between these two pointer. So the difference between I pointer minus start pointer, okay, as this is a zero based index, so we just need to add plus 1 to that. Okay, so right now this will be the what, right now this is L, okay, right now this will be length of this subarray. So we just need to check whether this length is, you know, smaller than this minimum length or not. If this length is smaller than this minimum length, then we'll simply initialize this length to this smaller length. Okay, and what we need to do, as we said that we also need to have a minimum window or minimum subarray. That's why we need to shrink the window from the beginning, so we can say our, and if we shrink the window, then we also need to, you know, reduce the, you know, starting pointer value. So that's why we also need to reduce, or we can say right now the sum will be nothing but sum minus equals to the value of the start pointer or beginning of the window. Okay, so beginning of the window pointer. So we can simply say, let's say array a will be the array, and we just need to subtract the value of what, the start pointer. Okay, so first of all, we need to subtract this value and we need to shift the window by one place. So that's why our start pointer will also increase by one value. Okay, so that is the thing we actually need to do. Okay, we need to do, you know, this loop until this condition satisfy. Okay, now let me do the second step. Now this will here. So first of all, what I need to do, you can say the sum was 8. So first of all, what I need to do, we need to check the length. So you can see the length is nothing but what, this is I pointer value of I pointer is nothing but 0 1 2 3. So I pointer value is 3 and this is 0, so actually 3 minus 0 is 3. Okay, but we need to add plus 1, so you can say the length is 4, but current now the minimum length was maximum positive value, so we just need to assign this as 4. Okay, right now the minimum length will be 4. Okay, now we'll be moving one step further, so we just need to reduce the sum. So we need to reduce the sum of the starting pointer, that is nothing but, you can see that is nothing but 2. So if we simply, you know, subtract sum from 2, this 2, so we'll be having a sum what, I will be having a sum 3 2 5 and 6, we'll be having 6. Okay, and you can right now, you can, and right now start pointer will be here. Okay, starting pointer will be here, and if we right now, if we again check the condition, you can see 6 is less than, so it will break and it will again come to this loop, and I will increase by 1, I'll be here right now. Okay, so right now we just need to add 6, add 4 with the sum. So right now you can see the sum is nothing but 6 plus 4 is nothing but 10, so it's also satisfy this condition. So what I need to do, we need to check the length. So right now the value of I is nothing but 4. Okay, so I is value 0 1 2 3 4. So right now this 4 minus the start pointer value is 1, and we need to add plus 1. Okay, so value will be 4, so it doesn't less than this small value, so it will remain same. Okay, and we need to reduce the, you know, start pointer value. Okay, if we reduce the start pointer value is nothing but 3. Okay, if we reduce the 3, so we'll be having a sum 7, and we also need to increase the start pointer. So start pointer will be right now here. Okay, so right now this is the start pointer. Okay, now you can see 7 it still satisfy this condition. Okay, then we need to again check the length. So you can see right now I is still here. Okay, so I is still 4, but the start pointer okay, but right now the start point is nothing but 0 1 2, so this will be 2. Okay, and we just need to plus 1. So right now if we check the, this value is nothing but, this will 2 plus 1, this will be nothing but 2 plus 1 is 3. Compare with that, so you can see 3 is less than 4, so we need to initialize the minimum value as 3. Okay, so now let me erase this, okay, first, so that we can be clear. Okay. So let me erase this first, and let me erase from here also. Okay, so what was the previous one? We have minimum length as 3, right? We have minimum length as 3. Okay, this is for loop, this is for, okay. Now right now you can see 7, so we initialize this. So what I need to do, we need to simply reduce the sum of the reduce the value of start pointer. So start pointer values, you can see this is 1, we need to reduce 1, so right now we'll be having 6. And you also need to increase the start pointer, so right now start pointer will be pointing here. Okay, okay, so right now you can see our sum is 6, so it doesn't satisfy this condition, so it will again come back to this loop, and I will increase by 1, and right now I will be here, and we just need to simply add the current element to the sum. So you can see right now the sum will be nothing but 6, and 3, it will be nothing but 9. Okay, it will be nothing but 9. Then we need to check that this condition is satisfied. So what I need to do, we first of all need to find the length. So you can see right now what is the length. So right now you can see the value of I pointer is nothing but 0 1 2 3 4 5. So 5 minus the start pointer value is nothing but 0 1 2 0 1 2 3 minus 3. Okay, and plus 1. If we do this, you will able to see this will give us what, this will give us 2, and plus 1, this is 3. And if we compare with that, this is not less than 3, so it will keep same. Okay, so what I need to do, we need to reduce the start pointer value. So start pointer value is 2, so let's reduce this. So if we reduce 2, you will able to see 7, and we need to shift the start pointer by one place, so start pointer will be here. Okay, right now you can see the sum is 7, so again it satisfies this condition, and again we need to just find the length. So right now we're having the length, what, I is still at the 5 to 5th position, minus right now start pointer is nothing but 4, and we need to subtract 1 plus 1. Okay, so right now you can see the length is nothing but it's give us 2. Okay, so you can see if you compare this will be less, so we just need to assign 2 as a minimum length. Okay, as a minimum length. Okay, now, okay, now what I need to do, we need to again subtract the start pointer value. Start pointer value is 2 4, so let's subtract 4. So right now the value of sum will be 3, and let's move the start pointer by one place. Right now start pointer will be here, and again if the right now the current sum is 3, so it doesn't satisfy the condition, so it will again come back to this for loop, and for loop for I will increase by one pointer. Now you can see I is out of this index of this array. Okay, so this loop will end here, and basically throughout this process we get our result as 2. Okay, and simply when we'll be out of this loop, while loop, we just need to return this, this minimum length. Okay, but yeah, we just need to return that. But here is a trick. Okay, okay, let me first erase everything. So here is a trick. So we said that we already analyzed this, and this give us as 2. Okay, we just, okay, so last of all we just need to return this 2 result, but before that we need to check something. Okay, according to the question, just look out this problem. Okay, sometimes what's happened, sometimes our, we can't achieve the target sum, so in that case we need to return 0. Okay, so before returning we just need to check whether this minimum sum is exactly same what we initialize at the time of starting. Okay, that we need to check. Okay, if that is exactly equal to the maximum positive value, then we need to return simply 0, otherwise we need to return this value. Okay, so let's code the approach. So what I said that we just what I said, we just need to have some variables. We have a variable, the name is nothing but what, the name is nothing but sum. Okay, that will be used for adding every kind element. and we have another variable. Let's say we have a start pointer. Okay, start pointer, it will start from 0 also, and we need to have another variable that will basically keep tracking the minimum length. Okay, so let's name is min length. Okay, let's name is min, and we just need to initialize these with maximum positive value. So in we have integer dot max value, right? So we'll be initializing with this. Okay, now what I need to do, we need to use a loop. Okay, loop will start from 0, it will till length, so nums dot length, and every time I will increase by 1. Then what I need to do, we need to keep on adding, okay, every elements to with the sum. So sum plus equals the current element, and this will be nothing but nums of I. Okay, and when this sum will be greater than equals to this target value, then we need to just let me first initialize the condition. So while this sum will be greater than equals the target, okay, then what we need to do, we first of all need to find the length. So int length will be nothing but what, the current index, that is I, minus the start pointer, that is st, and we need to plus 1 because this is 0 base index. Okay, then we need to, this is the length, then we need to check whether this length is smaller than the this minimum length or not. Okay, so we can do this in a single statement without without using if. Okay, so what you can do, you can simply this min length equals math dot mean of min length and min length and this length. We just need to check between this. Okay, okay, now what I need to do, as we said, that we also need to reduce the value of the start pointer, because we just need to get the to get the minimum possible sub array, we need to reduce the window size, right, from beginning. That's why we also need to reduce the value. So right now sum will be minus equals this pointer value, that is nums of start pointer. Okay, and we also move the start pointer by 1 place. Okay, that is the thing. And when we'll be out of this loop, we just need to simply return this minimum length. Okay, simply return this minimum length, that is the whole code. But before returning this, as we mentioned in the code, that if something happens, like if there is no such sub array, then we just need to return 0. So we just, before returning this, we just need to check that if this minimum length is equal to the value that we initialize for at beginning. Okay, we just need to check whether this value is equal to the integer dot max value that we actually initialize at the time of starting this approach. Okay, this will be max. Okay, that is exactly same. If this is equals to this, then what I need to do, if this equals to this, then we need to return simply 0, because we don't have such elements, so that's why we need to return 0. Else we just need to simply return our answer, that will be nothing but min length. Okay, and that is the, if that is everything we need to do. Okay, so now let me run this code. Okay, so you can see I'm getting an error, so let me see what is the error. So you can see, okay, this will be this. Is there any error? No, we don't have other errors. Okay, length. Yeah, this is less than an I space. Okay. Now, okay, so you can see the test cases are running well. Now let me submit this to check whether we have error or it gets submitted. Okay, so you can see it gets submitted. Okay, so this is everything. So yeah, the time complex is nothing but big of n, and we are not using any space. That's why the space complexity is big of 1. Okay, yeah, that's it.